Okay, so if you remember, or even if you don't remember, sometime in Algebra 1, I believe we talked about systems of equations, which means you'd have two equations with x and y in them, and you would be trying to find the solution that made both of those things true. So a system of equations, for our easiest purposes, is two equations in two variables, and you have to find that part, those ordered pair, that ordered pair or ordered pairs that makes both of them true. Okay, it satisfies both conditions. In applications, it would be like in economics, if you had a cost function versus a revenue function and they intersected, that would be the place, the break-even point, where after a certain amount you would start making a profit. So that would be like a type of application for it. We're not anywhere near that, but just so you know that they're not for nothing. Okay, so a linear system is where we're starting with, where you have two lines. The solution is the point of intersection if you have the two lines. And if for whatever reason you've got parallel lines, you would find that there's no solution to that because there's no place where they intersect. There's nothing in common in that. So if we're going to solve by graphing, let's see if I can copy this whole thing, because I can tell right now it's gotten really off on the way that it looks, and I want you to see this happening. So let's put this on here and see if it comes out good. Ah, yes, perfect. Okay, we can draw on it, it'll be great. Okay, so I want to solve this system by graphing. So in order to do that, I need to graph these equations very, very, very precisely. Okay, so in order to do that, what I need to do is I need to solve each one of these for y so I can get it in mx plus b form so I can make a very precise graph. So if I have negative 3x plus 2y, how do I solve that for y?
Subtracting.
You added this one.
Or I've added, sorry.
So we'll add the 3x because we're putting it in slope-intercept form. So I have 2y equals 3x plus 8. And then what do I do?
Divide by 2.
Divide by 2. Divide everything by 2. So y equals 3 halves x plus 4. So let's go ahead and let's make a graph of that. So I'm going to give myself plenty of room.
Which is that equation
Graph. If you need rulers, or if you need straight edges, rulers, they're over there. Okay, so we'll make our x and y axis. All right, so where do we start it?
Start at the y-axis.
Start up 4. 1, 2, 3, 4.
Start right 3.
And we
You
go
go up 3 and then to the right.
up 3, right 2. 1, 2, 3 over 2. I'm just going to make a bunch of them. 1, 2, 3 over 2. Now, because we have to be like super, super, super precise, I'm going to continue the pattern. If I continue the pattern this way, which way do I go?
Down 3.
Down 3,
Yep.
left 2. Because negative 3 over negative 2 is the same as positive 3 over positive 2. So we can go down. I just want to make a whole bunch of them. And then take your ruler and make your way all the way down through all of these. So there is our graph of that. Then we need to look at the other one. Make that another color so you can see nice. X plus 2y equals negative 8. All right, so once again, we got to put it in slope-intercept form. So what do we do?
Let's
So the intercept is y subtract x.
Subtract x. So 2y
That's negative.
negative x minus 8. Then we do what?
I'll divide by 2.
Divide by 2. It's not completely y by itself, so what does that look like?
Y equals 1/2 or negative 1/2.
Negative 1/2 x
Minus
4.
minus 4. So where do we start?
Negative
4.
1, 2, 3, 4. Negative 4, and which way do I go?
Down 1 over 2.
Down 1 over 2. Now the idea is that we're trying to find where they intersect. Going further this way doesn't help us. So then what's another way?
Up 1 over 2.
Up 1 over 2. Ah, yay, I've got an intersection point. That's good. But I'm going to take since it says solve by graphing, we really need to actually draw the line in. It goes through. And we found an intersection. Solving by graphing is kind of the longest way to find an answer, but it's the most telling as far as what your answer is representing, so it's a good thing to do. Here's our intersection right here. What's the ordered pair where they intersected?
Negative 4, 2.
Negative 4, not positive 2 though. Negative 2. Negative 4, negative 2. So the solution is negative 4, negative 2. Because we took our time to graph it, find where the ordered pair where it goes into both. So it will be a solution. If I did 3 times negative 4, negative 3 times negative 4, that will be 12. 12 plus 2 times negative 2, 12 plus negative 4 would give us 8. So yep, it works in that one. Negative 4 plus 2 times negative 2 would be negative 4 plus negative 4, which is negative 8. So yep, it worked in both of them. It made both of them true. That's the only ordered pair anywhere because it's the intersection of the two things. Okay. Everybody good? Okay, good. Let's go back and see how terribly mangled this was in the original thing that I have here. So, there we go. Negative 4, negative 2. There's our solution. It's not that bad. It came out pretty good. It's just this part that came out weird. Okay. Yep. Okay, well, whatever that was. Oh, okay. Yeah, they don't get that, no. Unfortunately. Huh?
I don't know if the nurse is here.
Yeah, actually we don't have a nurse today, so you got, yeah. I don't think, yeah, anyway. There's no nurse today anyway, so here we go. So negative 4, negative 2, checking it. This is what I did orally. When you plug it in, you get the value here, that's 8. This is negative 8, so it did work in both. And that's what I just said orally. You don't have to write it down if you don't want to, but that's how you know that it was correct. All right, let's look at the next one. Oh, calculator generated table.
Great.
So we can use a calculator generated table. Here is our y equals mx plus b form. So grab your calculator. I want to show you the table. Yay, I look good.
Where was it?
Yes.
Do you need to know this for the
The calculator table. I'm going to show you the table so that we can see where those values come from. But there's not going to be a thing that says do this thing in the table. Okay, there are some that will be easier to solve using the graphing thing, but there's a better way than looking at the table. But I want you to see it because it shows something. So what we're going to do, we're going to take our graphing calculator, let me clear that out so you don't get a headache from looking at it.
Okay.
We're gonna do y equals, push y equals. Okay,
Clear that.
and what I want you to do, is I want you to put the equations into these two places. So we're gonna do 3 halves,
Wait, top or bottom?
3
Oh.
halves.
3
3 divided by
3 divided by 2x
Oh, I'm looking at two.
for the top one, plus 4.
Wait.
So make sure there are no leftover
How do you
equations
do
here.
How do you get X?
X is
Alpha,
right
alpha,
here.
and
Actually, yeah, you could do that. That's a longer way, but for one step, it's like right next to the alpha button, where it's
Oh,
got an
I'm
X and a
blind.
T and a whole bunch of other stuff in it. So there's an X hiding right here. And then go down to the second y, because we have another y equation. Put in -1/2.
I've never known how to use calculators before this year. But
Is how do you find it?
The negative right
Negative
below
right
3.
here next to the enter.
Right below 3.
So -1/2 x minus 4. Okay.
bless you. Thank you.
There's the table. Okay.
-4. That's what it's supposed to look like.
Don't forget, 3 has x plus 4. Plus 4 on the top one. I'm using arrow to get there. So plus 4. Yeah, everybody has that in the calculator.
Oh, it's negative.
Okay. So what we're gonna do then is we're gonna go the second button, and if you go to the upper right-hand corner where it says graph, notice it says table up above it. You can't really see that, but you can.
Yeah, I see it.
Okay, so hit that,
Boom.
and it gives you a table of values.
I'm locked in.
I did not. I did not. I got a graph.
Right, so hit
You have to
second,
second before you press graph.
and that'll give you a table.
That's
Wait,
what
let
I
me see yours.
did. That's what I did, but I didn't do it.
You didn't press
do it. But I did.
Clearly not.
Well, clearly you didn't. But I did.
All right, so we have this table here. You may have different values here. Yours may not be going by 0.5s. Yours might be going by different ones.
I don't actually know what I'm going with.
Okay, but what this is giving you is for every x, it's giving you what y1 equals, it's giving you what y2 equals. So it's giving you what each value would be for both of them. So we'd have some ordered pairs. You'd have 0, 4, you'd have 0, -4. You would have,
I'm so lost with that.
Yeah, that's what I'm.
okay.
No idea.
Ah.
Okay, so what this is giving you, y1, okay, does everybody have a table in front of you?
Yeah.
Okay, so push
Wait, no.
second.
Person, you just hang on it. Oh,
Okay, so we have a table. Yours may not, okay, everybody's probably started at 0, but just in case, pay attention, look up here, look up here, look up. Okay, so up here, if x is 0, if you plugged in 0 here, you would get 4 in this equation that you put into y1.
What?
If you plugged in 0 for x,
Okay.
What?
if you plugged in 0 for x, 3 halves times 0, don't do it. Just listen because I'm telling you what numbers you're seeing up
You
here.
would get 4.
The idea is to not have to do this, but to be able to see what you would get. So if you plugged in 0, you would get 4 for this equation. If you plugged in 1, you would get 5.5. If you plugged in 2, you would get 7. So instead of plugging in all those values, it's giving you a list of the ordered pairs that you would get. For the second one, if you plugged in 0, you would get -4, which is in the second column of y's. If you plugged in 1, you would get -4.5. So this table is just telling you what values you would get if you took the time to plug them in.
If you plug in -9, you get -9.5.
Yeah.
Yeah.
Yep.
Great, Maddie.
So here's the thing, the arrows can take you to other values on
You
here,
can go to negative.
okay? So we can get negatives and we can get positives. Now, what was our solution that we found?
-4, -2.
-4, -2,
How'd you
okay.
get that?
Use the
The
arrow
bracket one,
keys.
Huh?
Use the arrow keys, you see them? right here.
What
Yeah,
number
you
you
said
at?
find where they match. They
Okay.
match at
So
4
listen,
or -8 and -8.
Can you like make that bigger?
I actually can't.
Oh, okay. No, just
So,
over.
like, it doesn't, no,
I
Yeah.
literally cannot see those numbers.
so, yeah, no, you don't have to see the numbers because you see it, but you can see that I'm telling you to push on the arrow keys, right?
So you guys know what number?
Okay, so listen up. This is why I don't like using this as saying solve by using this method. I'm just showing you that what it's doing when you look at a table and we're looking at the values. We said that -4, -2 was our solution. So if you use your arrows until you get to -4 in the X column, okay?
I am there.
Okay,
I have
notice
10
that
and-
on the Y1 column, it says -2.
I have
And
10.
also on the Y2 column, you should have -2.
I have 10 and -2.
Are you at -4?
You put something in the first one down there.
Oh, this should be positive 3/2. Because we have 3/2, you put in -3/2. So that's it. So you can just click delete. There you go. And now, yeah,
So you always start going.
there we go.
Because so what I did is I went up.
Jen, you
until
on
I
back?
found
What you going
Yeah, you went up until you found it.
Is that okay too?
Yeah, it really doesn't matter how you go about finding it. So the only reason I keep this in is because I want you to see where the table of values lives.
Wait, but my question is,
And
what are you trying to find what matches the Y1 and Y2?
where the Y1 and the Y2 are the same
Oh,
value.
alright.
Because that's where the solution lives.
So what if
Okay.
I went up instead of down? Would I end up having a different answer than that?
If you went up, no, because there's only one solution in the whole universe.
So you're gonna
So
skim through
here's
till you find it.
here's why I don't like using this as a method. Because if you start heading in the wrong direction, it might take you a while to realize that the numbers are getting further apart. So it's a lot of button pushing, not very efficient. Okay? However,
I'm at
I
-4.
showed it to you, not as really necessarily a way to solve it, but to show you that you can see lists of the values that you would get in here, and we're looking for where the -4 gives you the same value in both of them. Okay? So we're not really going to use this as a method for solving, but it's just something for you to know that your calculator will do that. So basically, if you didn't understand it, you don't have to do it anyway. So
So
don't
what's a
worry.
faster way to do it? How would we do it?
Okay, so a faster way to do it,
Wait,
I will show you a faster way with the calculator, but not right now. Okay, right now I just wanted you to take a look and be able to put equations
wait,
in.
I gotta get back to 0.
Okay, so you don't have to, yeah, they don't have to do anything here. So we're gonna solve that, and we're gonna do this again. I believe this was one they want you to do by graphing. Yeah, we're gonna solve this one by graphing as well. I'm sorry, I need a graph, a blank graph.
A positive divided by a negative is a negative.
Okay, so let's put this into,
Yes.
put it into y equals form first.
Oh,
Okay,
yes.
put it into y equals x plus b form first. Okay, so each one gets into slope intercept form. Okay,
Wait. Yeah. No.
okay,
A negative. No. A positive divided by a negative is a negative, right?
right. So a positive divided by a negative, but negative divided by negative is positive. So when we divide both sides by -2, you should end up with 1/2 x minus 2.
Yeah.
And the other one should be y equals -3x plus 5. Okay. So then I want you to very carefully make a graph, count your rise over run, and see where they intersect each other, just for your own practice.
The graph would be, the calculator would be a way to like double check yourself.
The calculator is, yeah, you could use the table for that, but I'm going to show you that there's more things that your calculator can do that would be way faster than, once you get the hang of it, it's faster. It's just a matter of sometimes
Aren't
people
there
are
like
like,
also
what?
problems? Aren't there also like problems like this where you have to solve it just like those two? You have to like find a.
Yes,
Okay.
we're gonna be
That's-
using substitution
I
and
hate that.
elimination.
I hated that.
Yeah,
I think I failed algebra to get that part.
okay, so we're gonna make sure you don't this time. All right, so plug in, make your graph, and then let's see what you get.
Can you get half?
I don't think this one comes out to be a half.
Oh, great.
So start, where does this one start?
-2.
-2 and then
Up 1 over 2.
up 1, right 2.
Up one, right?
I had put them away because some people were throwing them and I found broken ones and I found things against the wall. If you would like to use one column, you're going to.
You want me to tell you exactly who it was, Miss Deb?
You can get one.
I could tell you exactly who it was, too. James Esabante,
Oh, you-
Christian Vanilla, and Gabriel Vienna.
All right, so everybody who's listening to this, you just heard you just got called out, so it's the exact name of who was doing, so it's put away, but if you're using it for your purposes, that's perfectly fine. All right, so, we're going, that's why we're having assigned seats when you get back, because everybody's got to act.
Thanks, James.
when they
That's
get
crazy.
back.
Good job, guys.
Okay,
Love you.
I mean, some of you, you had assigned seats before, but then I kind of let people, but just no. And I'm not like people who are, I'll just, so I just can't have like that back row kind of like it was before. Anyway, here we go. So what'd you get?
2, -1.
Yeah, 2 and -1. So this one starts at -2, up 1 over 2, up 1 over 2, up 1 over 2. This one starts at 5, down 3 over 1, down 3 over 1. It lands right on the same exact point. Now, what you brought up is that if you're getting halves or thirds, it's a horrible way to solve it. Because you're not able to get on a graph, you're not able to get precise enough to know the exact half values or quarter values or anything like that. Yes.
Would if it turns into a -3x, would that not go the left one? Because one is a -3, make that a -1 as well. So then
Ne-
this is like
-3 over -1 would be +3.
oh,
So it's got to be over +1. So down 3, right 1.
I am so I do that.
Down 3, right 1.
There were some questions on the PSAT that were like the first one. I had no idea what the frick to do.
Because you didn't remember.
Yeah, and I'm kind of sad now.
Because you're like, wait, if it was just the next week. Yeah. Okay.
I didn't know this one, but
So-
I didn't know what to do on the calculator either, so that probably would have been even more complicated.
Right. So right now we're getting all of that stuff. So by the time you take this
SAT?
by the time you take the SAT, even if you take it in the spring, you're gonna have a whole bunch more
Yeah, I'm
stuff.
taking
that
mine
you
You
can
think
write.
we could agree there?
Okay, so I don't know. All right, moving right along. Okay, so let's take a look at this word problem. Okay. Ice cream cones. Wait, ice cream can use systems of equations? Yes. Ice cream cones cost $2 for a small cone and $3 for a large cone. I would never solve this by graphing, by the way, but we'll just go with the setup for this problem.
No, until 14 is probably
Well,
$39, how much?
I think we don't end up solving this with graphing anyway. So $2 for a small cone, $3 for a large cone. Those are the costs of the cone. Everyone on the team of 14 gets a cone. So this is not a money part. This is a number of cones. A number of people within, and each one got one ice cream cone. So if they spend $39 in total, so this is actually pretty cheap ice cream. How many got a small and how many got a large?
I don't know.
Okay, so in Algebra 1, we would have tried to wrestle this through with just one variable, but we're going to be able to make more convenient equations now with two variables. Yes.
I think it's an easier way to do it.
Okay, well, without guessing check, I'm going to show you how to do it with equations. Okay, so we would think of like the number of small cones as being one variable and the number of large cones as being the other variable. So you can choose X and Y, or you can choose other numbers. I'm going to choose X and Y. X is the number of small cones, Y is the number of large cones, just so that we can keep it with X's and Y's. No. It could be reversed. I chose X for the number of small cones, Y for the number of large cones, yes.
Would you set it up as 2x plus 3x equals 39 and then put that into ym equals mx plus 3 and solve it?
You could set it up, okay, there's actually, you have to have two equations. So
Okay.
2x plus 3y equals 39 will be one of them. That's your money equation.
What?
2x, 2 times the number of small cones, plus 3y, 3 times the number of large cones, equals $39, because that's the cost equation. So we would have that for sure. The other one has to do with the number of cones. So how many cones are there altogether from this problem? 14. So what will represent the 14? The number of the smalls and the number of the largest together. So we would have x plus y will equal 14. We don't need a z.
That's one equation.
So here's the number of equation.
Teachers, please excuse the interruption. Middle school soccer needs to be dismissed at this time. Middle school soccer.
So x plus y, the number of small cones plus the number of large cones equals 14 cones. Elisa said the money equation, she said that, let's cover that all up. She said that 2x plus 3y equals 39. That's our money equation.
So wait, why did we start with the x plus y equals 14?
You could do the money one first if you want, but we need two equations because we have two variables.
Isn't there like a simpler way to answer this without any equations?
Should be.
If you did guess and check,
Yeah, like,
but guess and check doesn't get you to where you could do, well, it doesn't get you where you could do complicated equations where it doesn't come out to be a whole number somewhere between 0 and 10.
what if I
So like a lot of times, unfortunately, artificially in Algebra 1, a lot of times the answers are chosen. So you're always going to get a simple number. So guess and check almost seems very efficient. But in real life, you might have numbers in the hundreds or the thousands with all the decimals in between, and you need to find the exact answer. So you need to know how to make that happen. Okay. Go ahead, Paul.
what if I'm on the quiz and I use a guess and check instead of the quiz when I get points off and I answer the question?
If it says write an equation and solve, then yes, because you need to be able to learn the method. Okay, so x plus y equals 14. So if we set it into y equals mx plus b form for graphing,
Which one?
okay, both of them.
Oh, so you need two equations.
So we need two equations because we have two variables, otherwise you can't solve them. So putting this into mx plus b form, we have y equals, how much?
X plus 14.
So negative x plus 14, right? All right. If we want to solve this one for y, we get
3y equals negative 2x plus 39.
3y equals negative 2x plus 39 because you take away 2x from both sides and then divide by 3, so you have this.
13. Yeah. That's what I got.
Yeah.
Go ahead.
And theoretically, you could graph that thing, which I really don't want to do. Theoretically, you could put it in your calculator and keep scrolling around until you found the right answer, which I really don't want to do.
Wait,
So-
how would I put that into my calculator?
Okay, so the way you put it in, you'd put y equals negative x plus, you'd like literally write it in like this. Okay, but I'm not going to, and I'll show you where the answer lives, but we're going to find, for this exact problem, we're going to find a way easier way of doing it. So I'm just right now more interested in you being able to learn how to set up an equation. So negative x
So we're not
plus
solving it
14.
basically?
I'm going to show you the answer, but I'm not going to have you solve it this way.
Could we if we want?
You can, but there's going to be such an easier way.
With the calculator?
Yeah, with the calculator that I don't want to
Okay.
I don't want to spend hours learning this when it's like it's the hardest way and you don't have to use it. but I want to show you that it exists.
Alright, so I got that.
So, if I were then to look at the table, second table, and I would have to just keep going around until I found the one, we know it's not a negative number of ice cream cones, so we'll go up here into the positive zone.
I'm gonna find it and tell you. You got it.
So
Oh,
when x equals 1, no, we have to find one where they both,
I'm at 33 and still haven't found it.
I'm at 3.
Found it?
Start at 0, 1, 2, 3.
We got
3
11 and 17.
is 11 and 11.
Oh.
Okay, when you get to 3, both of them are 11.
I got 33 and 11.
So somehow you put them in the equation, in the calculator wrong.
Oh, is it supposed to be negative x?
Yep,
I put
negative x plus 14.
Negative.
Negative x plus 14. So theoretically, if you go to the table and you go down, we find that it's, the ordered pair is 3, 11. So x is 3 when y is 11, and that's when they match.
Hey, can you go back to the part thing?
You're at 3? Oh, yeah.
You have to y equals.
Yeah, like. That's what I had.
You have negative x plus 14.
Oh, I put negative x plus 39.
Okay, so, yeah, so if you don't get it in there perfectly, so here we go. So 311 is
We
the
had to put this
solution, but what does that mean? 311 means that we have x is 3, which is the number of small cones. So 3 small cones and 11 large cones.
How do you know which one's small and which one's large?
Because we
you
put in
x
x,
equals small and y
Right.
equals large.
What if y?
And they would flip flop.
if y equals the small, then you would have 3x plus 2y, and you'd have a different equation to put in, and it would still give you, it would give you 11, 3 as your answer instead.
That's right. I got that.
Wow, everybody was at a large one.
Not
That's not
negative
too bad,
2x,
really.
just negative x. You have negative 2x.
Yeah, I spent 50 on the light.
Oh, so you take the top problem.
You take this
What?
one right here.
Why did it?
Wait,
If,
which ones? Which one do you use?
This one and this one. You can't, it's not y equals negative 2x plus 14. You put y equals negative 2x, it's just y equals negative x.
if it was, if 39 divided by 3, that's 13, right? Why didn't, well, I just put it like 39 divided by 3, 13. Why did you tell me no? Somebody didn't have $3 more to get the 14th guy a large.
Anyway, it could have been that the 14th person did not want a large because it doesn't say,
Okay, no,
it doesn't say who's on the team. Okay, if it was me, well, I don't know, I would make my choice. It would depend on how big the small and the large were.
Ever gonna bring this to us?
I don't know, do you want me to?
Yes. Play
Wait,
a song.
what?
What song?
Tuba.
We can play you know
Alright, let's.
you know the song by John Legend. It's like what would I do? Yeah, that song. I play the piano. You can play the tuba.
Alright, let's keep going. Let's keep going.
I thought you were supposed to eat your way to do that.
No, I'm not showing you an easier way yet. We're gonna get to the easier, we're gonna get to the other ways of doing it, but I can't show you right now. Okay, so the idea is there are some words that mean these different types of solutions. Okay, so if they intersect in one spot, they have one solution. The words that go with that is consistent, meaning that they have a solution, and independent, meaning that they're two different lines.
And parallel means no solution.
Okay. Parallel means no solution, so you can write that in. Parallel means no solution, so if you get two lines that don't intersect, we call that inconsistent because there's no solution. And if there's two lines that are actually, you graph one and you graph the other one and it turns out to be the same line, okay, we would say that there are infinite solutions and they're dependent on each other because it's really the same line in disguise. And we call that consistent and dependent.
What?
It's just the words that mean if you graph them and you get two different lines and they cross each other, it has words that go with that, consistent, independent. If we find that they're parallel, we'd say there's no solution and the word that goes with that is inconsistent. If we find that we graphed two lines and they ended up right on top of each other, so it's the same line, we say there's infinite solutions, and the words that go with that is consistent, meaning that yes, there are solutions, and they're dependent because they're not the same line. Here, in terms of slopes, listen up. If they intersect each other, they have to have different slopes. Okay? Because the same slope would mean that it was parallel or it's the same line. So same slope only happens when they're parallel or it's the same line. If they're parallel, they have different y-intercepts. Okay? Having an intersection has different slopes. They might have the same y-intercept. We don't even know anything about the y-intercept here. But if it's coincident, in other words, the same line on top of each other has the same slope and the same y-intercept. So this is just for your vocabulary. You all right, GD? And so that's kind of a vocabulary thing. And
You were his show out.
And I'm looking at the next thing.
You got 30 minutes.
I think we need to stop right now because I think the next one is mangled on the present, so I just need to
I only
stop.
got 3 minutes, so.